Assalamualaikum and hi, my name is Aminul Naim bin Kamal Afandi. My numeric number CD230202. Today we want to present about modeling heart rate response using a numerical method. Heart rate shows how well the cardiovascular system works. During exercise, the heart rate increases to supply more oxygen to the muscle. After exercise, the heart rate decreases during a recovery, which shows the body recovery ability. In this project, her data is recorded at a fixed time interval using a smartwatch. Because the data is not continuous, numerical methods are needed. Interpolation is used to estimate missing heart rate using a value. Different is using a find how fast the heart rate change. Integration is used to calculate the total cardiovascular workload. This project shows how numerical method learned in the UTHM can be applied in real-life engineering data. In this project, we choose stair climbing because it is simple, low cost, and efficient physical activity. In Vision increase a heart rate within a short period and does not require a special equipment. In addition, the stair climbing engages a large muscle group in the lower body, making it suitable for study cardiovascular response. Mostly importantly, activity can be performed consistently by a different subject, ensuring fair and reliable data comparison. Therefore, this project demands the practical apply of a numerical method in analysis real physics data obtained from smartwatch measurement. In this project,
Hello, my name is Muhammad Syarish Fakir bin Saifuddin, CD230180. So now we go to the data collection. For the first one is rest phase. Alright, during the rest phase, both subjects were sitting or standing quietly before starting the exercise. Their heart rates remain relatively stable during this period. Alright, subject A, which is Siraj, recorded heart rate value of approximately 85 to 90 beats per minute, while subject B show slightly higher values ranging from about 85 to 92 beats per minute. So this phase represent the baseline heart rate of each subject before physical activities. During the exercise phase, both subjects perform stair climbing at a steady pace. Okay, at the start of the exercise, as you can see, a sharp increase in heart rate was observed for both students. Alright, student A heart rate increased to approximately between 140 and 158 beats per minute, while student B shows slightly higher values, reaching up to around 160 beats per minute. So the fluctuation in heart rate during this phase reflect change in exercise intensity and the body's psychological response to physical activities. Okay, now we go to the recovery phase. Alright, during the recovery phase, both students stop exercising and remain at rest. A gradual decrease in heart rate was observed for both students. Alright, student A, which is Siraj, heart rate decreased more rapidly from around 110 beats per minute back towards 90 beats per minute. In contrast, student B's, which is minimum heart rate, decreased more slowly and remained above 100 beats per minute by the end of the recovery period. So this indicates that students A had a faster and more efficient heart rate recovery compared to students B.
My name is Anissa Tira binti Zamrilais Johari. My matrix number is CD230131. And for today, I'll be explaining about the Lagrange polynomial interpolation. So when I'm doing the Lagrange polynomial interpolation, I'm using 2 points, 3 points, and 4 points. So the value that I will be using is from around 60 until 150, which is 60 seconds, 90 seconds, 120 seconds, and 150 seconds. And for 2 points value, I get 88.5. 3 points value 88.8, and 4 points value 85.2, which is after I've done the free math, I put all the value in the free mat, I get the same answer with the free mat. And for person B, which is Amino Naim, for 2 points, I get 88.5 beats per minute. And for 3 points, 88, and for 4 points, 87.8, which is same as the free mat value.
My name is Jeffrey Hussein. I will explain how numerical differentiation is used to analyze the rate of change of heart rate over time when the data is collected at discrete time intervals. In this analysis, the two-point forward difference method is applied. This method determines the rate of change by comparing the heart rate at one point with the heart rate at the next recorded time point, then divided by the time interval between them. The heart rate data is recorded every 30 seconds, so the calculated values represent how quickly the heart rate increases or decreases during each 0.5 minute period. So from the graph, subject A exhibit larger and sharper fluctuation with high positive peaks around 120 seconds and at 240 seconds, indicating a rapid cardiovascular response, and a larger negative value around 420 seconds suggested that fast recovery or sudden reduce in activity. In contrast, subject B shows smaller and smoother variation with a lower maximum rate of increase, indicating a more gradual and stable heart rate response. So overall, subject A demonstrates a more instant heart rate response, while subject B show better control and stability.
Okay, hi. My name is Nur Saida binti Azhari. My matrix number is CD230061. So for this part, I will explain the trapezoidal rule method. This method used to estimate the area under a graph when it is difficult to calculate it exactly. In this study, the graph is heart rate versus time, and the area under this graph represents the total workload of the heart. First, the time interval from S0 to Sn is divided into n equal segment. Here, n is the number of segment and it must be a whole number. The size of each segment is called h, and it is calculated using h equal to xn minus x0 divided by 2. Next, the curve is divided into trapezoid shapes. Each trapezoid use two heart rate values, one at the beginning and one at the end of the time interval. The trapezoidal rule works by adding the first value and the last value, then adding twice the middle values. All these values are multiplied by h divided by 2 to get the total area. Okay, now we move to the next slide. Alright, this slide shows the total workload for the whole season, which includes rest, exercise, and recovery. The total workload is calculated using the trapezoidal rule on the heart rate versus time data. For Siraj, the time range is from 0 to 720 seconds with equal time interval. Using the trapezoidal formula, all the heart rate values are added based on the rule and multiplied by h over 2. So from the calculation, the total workload for Siraj is 83745 beats per minute. This value represents the total heart rate effort during the entire season. Alright, for Mino, the same trapezoidal method and time interval are used. From the result, the total workload for Mino is 88320 beats per minute. Okay, for the exercise phase, the trapezoidal rule is used to estimate the total heart rate response from 150 to 420 seconds using equal time intervals. For Siraj, the calculated total heart rate response during exercise is 39645 beats per minute. For Mino, using the same method and time interval, the total heart rate response during exercise is 37620 beats per minute. This shows that Siraj's heart rate works slightly harder than Mino during the exercise phase. Next, for the recovery phase, the same trapezoidal rule is applied to the heart rate data from 450 to 720 seconds to evaluate how the heart rate decreased after exercise. For Siraj, the total heart rate response during recovery is 26130 beats per minute. For Mino, the total heart rate response during recovery is 32625 beats per minute. A higher value during recovery indicates that the heart rate remains elevated for a longer time. Okay, this slide shows the validation of our result using software, which is Freeman. The trapezoidal rule was applied in Freeman using the same heart rate data and the same time interval as in the manual calculation. First, the validation was done for the whole season, which include rest, exercise, and recovery phases. For Siraj, the total workload obtained from Freeman is 83745 beats per minute, and for Mino is 88320 beats per minute. These values are exactly the same as the result obtained from the manual trapezoidal calculation. In addition, the exercise and recovery phases will also validate separately using the same method in Freeman. The software result for the exercise phase and recovery phase match perfectly with the manual calculation for both Siraj and Mino. This confirms that our manual calculation using the trapezoidal rule are correct and accurate. Based on the comparison on the numerical differentiation result, Siraj has a higher maximum positive rate of change of heart rate during the exercise phases compared to Mino. This means Siraj heart rate increased faster when exercise start, which indicates that Siraj experienced a higher workload during exercise. But during the recovery phase, the differentiation result showed that Mino has a more negative rate of change of heart rate than Siraj. This indicates that Mino heart rate decreased faster after exercise, so Mino recovers more quickly. Okay, from the integration result, Siraj has a larger total integrated heart rate value compared to Mino. This means Siraj heart rate stay higher for a longer time, which confirms a higher overall workload. This agrees with the differentiation result previously, where Siraj showed a faster increase in heart rate during exercise. But for Mino, the integration value during recovery is smaller, which match the differentiation result showing a faster decrease in heart rate. This confirms that Mino recover faster. Therefore, the integration result support the differentiation result, and both methods lead to the same conclusion.
Alright, in conclusion, this project successfully modeled the heart rate response of two students during rest, exercise, and recovery using numerical methods such as interpolation, numerical differentiation, and numerical integration. The interpolate data help complete the data set and allow accurate analysis. Okay, from the different results, student B show a faster increase in heart rate during exercise, while student A recovers faster during the recovery phase. Alright, the integration result using the trapezoidal rule show that student B had a higher cardiovascular workload, especially during exercise. So do highest heart rate values, and then this result are consistent with the differentiation findings. However, this study has some limitation such as a small sample size and possible measurement errors. In the future, the study can be improved by using more subject or student, more accurate device, and advanced modeling method.